Okay, I just wanted to quickly go over this question. It says one number is 5 times a first number. A third number is 100 times is 100 more. No times, sorry. A third number is 100 more than the first number, and the sum of the three numbers is 1927. Okay. Yes, this is very challenging. The sum means add, right? The sum of three numbers, A, B, and C is always means equals 1927, for example. Good? Okay, so we know we have three numbers. We don't know any of these numbers. The question asks us to find these numbers. So we need to find A equals, B equals, and C equals, right? But what we've been doing in this unit is only solving in terms of one variable, right? These are three different variables because they're three different numbers. And so we represented the three different numbers with three different letters, right? If one number is 20, the third number is 104, and then B is a first number, right? So B would be one number in this story. Just because they call the next one a first number, that would be our A. A first number. Good. And a third number we have. Is that okay? So now we have three numbers. The sum of them is 1927. Now we just need to find these three numbers, right? So instead of having three variables, because what we have been practicing in this class is how to solve something if it was in one variable, right? 5x plus 10 equals 30. We subtract the 10. We get 20 is 5x. We divide by that 5. And we get x is 4. Right? We can solve it when we have one letter we can solve it for. So this one letter was x. We move everything else over because everything else are numbers. Here, though, we have A, B, and C. So that is our problem. We need to take that A, B, and C and turn it into that same addition equation, but with only one letter instead of three letters. Okay, so that one number is 5 times a first number. A third number is 100 more than the first number. The sum of the three numbers is 1927. So let's look. A first number. A first number, okay? The sum of the three numbers is 1927. So the first number we can just leave as A. The first number remains A. Good. And then we need to write the letter B. We call it in terms of A, okay? One number is 5 times a first number. So B becomes 5 times a first number. What letter, so 5 times means we're multiplying, right? What letter did we give to a first number? We gave it the letter A. A first number is just A. So B is actually 5 times the letter A, or just 5A. Because we said one number, which we labeled B, is 5 times a first number, which is our letter A. So B is 5A. The last one, a third number is 100 more than the first number. So just to note, one number is 5 times a first number. So we said B is 5 times A. And now we have a third number. A third number is 100 more than the first number. A third number, which we're calling C, is 100 more than means plus, right? The first number. What's the first number? The first number is the same as saying a first number. So we're saying C is 100 plus, what's the first number? A. Good. So we have our original A. Keep that same plus sign because it's still a sum. B is now 5A, right? So we have A plus 5A to show the second number. Keep that plus sign. And C we decided is 100 plus A equals 1927. So we took 3 different numbers and we put them all in terms of the first number because they gave us the information in these sentences to describe the next number in terms of A and the third number in terms of A. Now we're just combining like terms, right? A and 5A and A, 5, 6, 7 becomes 7A plus 100 equals 1927. Subtract 100. We get 7A equals 1,827. Divide both sides by 7. And we get A equals 1827 divided by 7, 261. A first number is 261. One number is 5 times a first number. So 5 times 261 becomes 1,305, sorry. And then a third number is 100 more than, 100 more than the first number. So that's 100 more than 261, which is 361. So when they ask, what are the 3 numbers? We have 261, 1,305, and 361. So your numbers will be different, but that's how you solve it. So you decide what each one is, and then you put them in terms of the first number.